So far, we have covered the basic of JavaScript, data structures, and strings in the previous videos. And now we will explore two more data types that are essential, and these are numbers and dates. Now, in this video, we are going to explore how numbers works in JavaScript, how to convert values to numbers, and how to check if certain value is number or not. So let's get started. So first of all, we are going to learn how number works in JavaScript. So in JavaScript, there is only one data type for numbers, which is called number. And unlike some other languages, JavaScript does not have separate types for integers and floating point numbers. This means that we can use the same type of variable to store whole numbers and decimals. For example, let's say we have a variable called x with the value of 10, which is an integer, and one other variable which we are going to call y with the value of 3.14, which is a decimal value. However, this also means that we have to be very careful when performing arithmetic operations on numbers, because JavaScript uses a binary representation of numbers, which can cause some rounding errors. For example, if we try to add zero point 0.1 with zero point 0.2, we might expect to get zero point 0.3, but instead, if we log this z variable, you can see in our console we are getting 0.30004, and this is because zero point 0.1 and zero point 0.2 cannot be represented exactly in binary. So there is a small difference between the actual value and the stored value. Now to avoid this problem, we can use methods like toFixed or toPrecision to round the result to a certain number of digits, such as to round this number we can write z dot toFixed, and if we call this method, and if we use 2 for our decimal places, and if we hit save, you can see in our console now we have our rounded number, which is 0.30. And to round this number, we also have another method, which is toPrecision. And if we use this method, now if I hit save, you can see we have the same result. Now this 2 here represents the number of digits appear after this decimal point, and its value should be between 0 and 100. And if this argument is omitted, then it is treated as 0. Now another thing to keep in mind is that the JavaScript has a limit on how large or small a number can be. Now the largest possible value is this, and the smallest possible value is this 5e minus 324. Now if we try to use a number that is larger or smaller than these limits, we will get a special value which is called infinity or minus infinity, which represent positive or negative infinity. For example, if we create a new variable, if we write let infinity value is equal to largest possible value multiply by 2, and if we log this infinity value, and if we hit save, you can see in our console we have a positive infinity. And now if we divide a very small number by 2, like if we divide this smallest positive value with 2, you can see now we have 0. Now these values are not actual numbers and we cannot perform any arithmetic operations on them. We can use the Number.isFinite function to check if a value is a finite number or not. Now to check this, we can write console.log and then we are going to write number, and on this we have a method which is .isFinite, and if we provide this largest possible value variable, you can see we are getting true. So this is a finite number, and if we do the same thing with this infinity value and if I hit save, you can see we are getting false, and it is because this is not a finite value. And now we are going to learn how we can convert values to numbers. So sometimes we might need to convert a value of another data type such as string or a boolean to a number. So there are several ways to do this in JavaScript depending on the situation. Now, one way is to use the number object, which is a built-in object that provides methods and properties for working with numbers. We can use the number constructor to create a new number from a value. For example, let's say we have a number in the form of string like this. If we check the type of this variable, which is num, you can see this is a string. Now if we want to convert this string into a number, we are going to create a new variable. Let converted num is equal to, and now we are going to use our number constructor and we are going to pass this num variable, and if we hit save and if we check the type of this converted num variable, you can see now it is a number. So we can convert a string like this into a number by using our number constructor. However, this will not work for all values, and if the value cannot be converted to a number, we will get a special value which is called NaN, and this NaN stands for not a number. For example, let's say we have a string hello. Now if we convert this string using our number constructor and if we log the type of this n variable, you can see the type of n is a number, and if we check the type of this string variable, now you can see it's a string. But if we log the value of this n variable, now we have nan in our console, which means that the value of this n variable is not a number. But this nan is also not a real number, and we cannot perform any operations on it. So we can use the isNaN function to check if a number is nan or not. Now in order to do this, we can write console.log, then we have our isNaN method, and this method will return true or false. So if we check for this n variable and if I hit save, you can see we are getting true because this n variable has a nan value. That is why after checking using this isNaN method, we are getting true. Now another way to convert a value to a number is to use the plus operator, which is a shorthand for the number constructor. This works the same way as the number constructor. For example, if we want to convert this string to a number using our plus operator, we can write let converted number to. Now instead of this number method, we are going to use plus operator and we can write plus num. And if I hit save and if we check the type of this converted num to variable, you can see now it is a number. But if we check the type of this num variable, you can see it is a string. So you can understand by using this plus operator, we can convert a string like this into a number. However, this method also has the same limitations as the number constructor and will return NaN for values that cannot be converted to numbers. For example, if we use this plus operator with this string and if we write let n2 is equal to plus and then if we use this string to convert into number and now if we log the value of this n2, you can see we are getting NaN. So this is giving the same result as we were getting by using this number constructor. Now a third way to convert a value to a number is to use the parseInt, parseFloat functions, which are global functions that parse a string and return an integer or a floating point number respectively. These functions are more flexible than the number constructor or plus operator because they can handle strings that can contain non-numeric characters such as spaces or letters. For example, let's say we have a non-numeric string like 42 pixels. We want to convert this string to a number. We can use our parseInt function in order to do this. And we can write let converted is equal to parseInt and then we are going to provide this string that we want to convert and this is non-numeric and now if I hit save and if we log the type of this, so type of converted, you can see the type of this converted string is a number and if we log this converted variable, you can see we have 42. So this parseInt function ignores the pixel part of the string and returns only the numeric part as an integer. Similarly, the parseFloat function can handle strings that contain decimal points, such as if we have a string like 3.14. So now we have a decimal point and we want to convert this type of string into number. We can use our parseFloat method and we can write let n3 is equal to parseFloat and if we provide this string to this method and if we hit save and then if we log its value and then if we check the type of this n3 variable, you can see it is a number and if we check its value, you can see we have 3.14. Now however, these functions also have some limitations. For example, they will return NaN if the string does not start with a numeric character. Like if we change this string and if we add hello in start of this and now if we check the value and type of this converted variable, you can see the type of this converted variable is number, but the value is NaN. And similarly, if we have two numbers in one string, then this parseInt method will return the first valid number in the string and ignore the rest. Now if I hit save, you can see our parseInt method return the first valid number from this string. And now we are going to learn how we can check if certain values are numbers or not. As we have seen, JavaScript has some special values that are not real numbers, such as NaN, infinity, and minus infinity. So sometimes you might need to check if a value is a valid number or not before performing any calculations on it. So there are several ways to do this in JavaScript. One way is to use the type of operator which returns the type of value as a string. For example, you can see here we have three variables. First one is a number, second is a string, and this third one has a value of not a number. And to check the types of these variables, we can simply use our type of operator and then type of x, then y, and then we have z. Now if I hit save, you can see we have the types of all of these three variables. We have number type for both x and z variable, even though z is not a real number. This is because NaN is technically a number data type, even though it is not a valid number. Therefore, the type of operator is not very reliable for checking if value is a number or not. A better way is to use the number.isNaN method, which returns true if a value is NaN and false otherwise. For example, instead of doing this, we can write console.log, then our number dot is NaN. Now, if we provide here the variables that we want to check, like x, then y, and z, and if I hit save, you can see this number.isNaN function correctly identifies that z is not a number and this x and y as a number. However, this function only works for NaN values and not for other special values such as infinity and minus infinity. Now we are going to learn how we can check the infinity and minus infinity values. Now to check for infinity and minus infinity values, we can use the number.isFinite function, which returns true if a number is a finite number and false otherwise. For example, here you can see we have four variables a, b, c, and d. Here, this first variable is a very large number. Then this second variable has an infinity value. This third one is a small number, and this last d variable has the value of 0. And here we are using our number.isFinite method to check for infinity and minus infinity values. And as you can see here in our console, the number.isFinite function correctly identifies b as not a finite number and a, c, and d as a finite number. However, this function also returns true for this d variable, which is not a valid number for some calculations such as deviance. For example, here I created three variables x, y, and z. X has a value of 10 and y has a value of 0. And here I am dividing this x and y variable. And here we are using number.isInteger method. And as you can see, this number.isInteger function correctly identifies this z as not an integer. So that is why it is returning false. And that's all I want to show you in this video. So in this video, we have learned how numbers work in JavaScript, how to convert values to numbers, and how to check if certain values are numbers or not. We have seen that JavaScript has only one data type for numbers, which is called number, and that it can store both integers and floating point numbers. So I hope you found this video helpful and informative. If you did, please give it a thumbs up and don't forget to subscribe to join this web development journey with us. If you have any questions, leave them in the comments below. Keep coding, keep creating, and I will see you in the next video.